Hello, everyone. Thank you so much for joining us today. Before I start, first of all, I'll go through the code of conduct, which is just being so be welcome, respectful to everyone. As you communicate in the chat, as you interact with everyone, also remember to we are always open to questions. We're always open to questions and the different viewpoints. So as we continue, remember to ask any question that you might have on the chat. Before I go to today's speaker, who is Olan Rewanju, I'll give some few reminders first before then. So the first reminder is we're having a cloud
I think there are some technical issues there, Bethany. Okay.
about and to be able to learn more. So pasted the link to the Cloud Skills Challenge in the chat. Is at the end of the sessions, you should have some basic knowledge on how to work with Azure AI service. And from this, you can be able to go ahead and read on the exam for AI 900 and be able to take the exam. So I've also pasted the link on the AI 900 exam. Be sure to check it out and ensure you're able to do it. For students, it's free, so you can get the certification for free for a limited period of time. I'll also share that link for anyone who's interested in taking the certification for free as a student. Okay, over to you, Ola. He'll be talking about responsible ML and AI and talking about everything around the same. So over to you, Ola.
Hi, everyone. Good day, wherever you're joining from. So happy to be on this today. It's been a long journey, you agree with me, learning, data science and machine learning with Microsoft Azure. And I believe it's been an exciting journey as well. While you build many models, or you follow the tutorial, you build your own model, the topic of responsible machine learning and AI is something that we should discuss. And I have experience to share with you and to help you understand this today. By name, I'm Olariwaju Iboki. I'm a senior cloud advocate at Microsoft, and I have past experience building machine learning model in local development and so on. Okay, let's move on to what I have. If you see me looking sideways because my second screen is here, so I now have to check the slide that we're presenting. So, agenda today, why responsible AI and ML? Why should we think about this? Then we'll talk about what exactly is responsible AI and machine learning. Then, what are the principles? Responsible AI and machine learning principle. Before that, I'd like to crack some jokes here. Why the data scientists cross the road responsibly to get to the unbiased data set on the other side. I've always, pride myself being a comedian, working in the data domain. If this makes you laugh, if this is funny, let me see some reaction in the comment section. Of course, it's funny to me, if you don't understand yet, when we move and talk about the concept of responsible AI, you will definitely understand this, especially when we talk about unbiased data set, those keywords used in this joke. Okay, so while, we just laughed, in all honesty, responsible AI and machine learning is not a joke. That topic is something that should be taken very serious. And as a brooding data scientist, AI, experts that you are and you're becoming, you should start thinking about responsible AI and not just think about them, implement them in your solution. Personally, I worked 2 years building machine learning models and solutions and never thought of ethical or responsible AI. I didn't know what it is, neither do I know how it could impact what I was building. And I was building machine learning model, deploying solutions, for organization. There wasn't any consideration around, oh, could it be biased? Is it fair? Is it inclusive? Is it transparent? All those principles that we will say talk about. And while I walk you through these scenarios and these principles, it will be good for you to reflect on all the models you built in the past or in the course of this session that you built Of course, you should reflect and ask yourself, while building this model, at any point, did you ever thought of responsible solution? Did you ever thought about all these principles while building those solutions? That's how you can reflect and start changing and know where to trace back your step. For a data scientist or machine learning expert or AI, expert, you're always excited building the solution. So you might miss out on this topic, which is of also very high importance. Let me share with you some scenario to drive home why responsible AI and ML. You might be wondering, okay, why is it important? I've built models, the models are working, I've built AI solutions, deploy it, they're working. So what do you mean by responsible AI in all this scenario? Because I can't see them. Okay, let me cite some scenarios here. First, predicting surgical complications. In a scenario where you build a machine learning model or AI solutions that will assess some vitals in the system and be able to predict either there's going to be surgical complications, in medical fields or not for that particular person. If the data trained is biased, if it is trained, for example, with maybe older people because they are also the one having those aged issues with brain memory loss and the rest, and not bearing in mind the younger folks who might also have this similar challenge, in that scenario is biased, it's not representative of the entire population. So the solution might miss out someone who actually needs medical complication. And in that case, if it is detected earlier, the doctor could rescue that person. But if he couldn't detect because it was trained on aged people, then something has happened. It has failed us. We are at risk of losing a life just because the model bit was not unbiased. So this is one reason and scenario, because and this is a very delicate decision between life and death. So you have to literally be very conscious of this. So this one scenario. Let's look at another scenario. HR hiring process. I like citing this example because at the early stage of deployment of these HR assistance solutions all over the world, you see when you submit and apply for a pro role, ATS, all this application tracking system and the rest of them automatically pick your CV and analyze them and decide whether to move you on, move you to the next step or not. So, for example, biased resume screening. Machine learning algorithm that you built is used to screen resumes and can be biased, especially if trained on biased data. For example, if the training data is skewed towards a certain gender or race, then the resulting model in itself may be more likely to select candidates from that group. You have 90% male that were used. You could even across races, across geographical denomination, wherever people are domiciled. It was trained with people in the West, then Africans are likely to be left out because those keywords that the way we interpret or understand keywords and skills might be different. This thing, but you are saying I'm good with data analysis, and someone is saying I'm a data analytics expert. You are looking for data analytics guy, and that model is more closer towards the person that is saying I'm a data analytics expert than someone that says I'm good with data analysis. Meanwhile, they both of them can do the same thing. So here's another scenario. Someone who is qualified is at risk of losing opportunity to get a job just because the model is biased. And imagine what that means. In many scenarios, maybe you have applied to some roles, and that kind of thing has happened to you. In just few days, you get a we call it love letter. You get a rejection email. You are not even sure why. Why did you reject it? Just that we cannot move it forward at this point in time. What actually happened? In those scenarios, some of those solutions are actually biased. Those algorithms were trained on data that could not recognize you as skillful person, even though you are a match for that role. You know how painful it could be, and the impact it could make on the livelihood of that person who is looking forward to that next job, to change his or her own status. So start getting how not thinking about responsible and ethical solutions can its implication on not just yourself, the customers, and the entire, population. Another one is loan approval. Good. You could be in their need of financial support, and maybe there is no immediate no friend, nobody in your network will borrow you, afford you that money on, at that point in time. You resort into financial institutions, the fintech, whom you believe should assess you and give you and provide you the loan so that you can cover your pressing needs. Those scenarios, those situations, they are things that makes up our livelihood. And if you think, oh, we are just rejecting a loan, it's not just about rejecting a loan. So when you have a loan, algorithm, that is being built, whose role is to assess you and profile you and tell if this person is liable, is good to, borrow loan, an approved loan, or maybe this is the threshold we should give. And if the data used to train this is also biased, maybe because this person is not a salary earner. The fact that you are not a salary earner doesn't mean you are not qualified for a loan. Doesn't mean that you cannot afford and also pay back a loan. These are many scenarios today where people who, when you train an algorithm that is biased in one way or the other, and biasness is not just the only thing about responsible AI. We're going to talk about the principle, but I'm citing these user scenarios, live scenarios, so that you can see how decisions, we have all around us today, how machine learning models we are building can affect them. Imagine the emotion, deficit that happens to someone who needs money urgently to attend to a need and who is qualified, but because an algorithm has been trained and is looking for something else, neglecting the other trait that still makes someone qualified, and you get rejected. Imagine waking up on Sunday morning or Monday morning and going to work or trying to check your email, and all you got there is a rejection mail for a job you applied to that you actually qualify, but because algorithm someone has built and deployed limited your, made it impossible for you to get that dream job. Your choice. Imagine, someone who could have been saved if the situation was predicted earlier or way better, who could have been saved, of medical or surgical complications, ended up having it just because the model built and deployed it was biased. So this is why the topic of responsible AI and bias is very, very important as we continue, to build our skill and deploy our solutions. I would then share with you at Microsoft what are the responsible AI principles, because Microsoft doesn't just make the cloud available for doing more or to enable you to do all these things, as seamless as you see them. Go on Azure, build a machine learning model, build AI solutions, deploy them, leverage them, work with them, integrate them. It's not just about that seamless. At the background, while building the Azure platform, responsible solutions was part of the fabrics of what the team at Microsoft did. And what are the principles that is guiding this at Microsoft, which is also going to guide everything you do while you start building your solution on Azure. And I'm going to share briefly here. So these are framework that has been developed to guide your solutions. Yes.
Hello. You got lost a bit between the last slide on loan approval and starting this. So can you do the introduction again for the Microsoft principles?
Okay. Okay. Apologies.
Yeah,
Might be
no
network
problem.
instability. All right. So what I was trying to explain here in this scenario of loan approval is someone who needs loan urgently, but the algorithm, the machine learning algorithm that has been built, denied that person of that opportunity simply because it was trained differently. Example, the algorithm was trained to identify those who have regular stable income coming every month at certain day or with little variation, which is salary. When you receive salary is regular every month. And that way we believe, oh, this guy is getting something every month and pay back a loan. Then check for affordability. Can they afford this certain amount or not? But the person will definitely be approved if the affordability range is right. Compared to someone else who maybe is an entrepreneur, you don't have a regular stable income label, a salary coming every time of the month and base
Hello,
salary.
can you hear me?
Yes, I can hear you.
Hello.
Yes, I can. Yes, I can hear you.
Yeah, I keep losing you. Right now, you're lost.
I'm just trying to also be sure because I could hear you. Could
Yeah.
it be from my hand or from your hand? I can also switch my network. Just trying to validate if do you have any comment from the audience? Probably it's from my hands so that I can be sure.
No, 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 no comment yet. But you can continue
Ah,
for now. Yeah.
okay. Good. So, as described earlier, when your model is biased, you it affects lives. People who need this, who are under financial stress, and whose this loan could have solved that issue for them. Oh, okay. I got feedback that it's likely Bethany's network. Okay, so it's easier for me to jump to the next topic now because I've tried to explain this concept wise. Okay. All right, thanks. So at Microsoft, we have this framework as which also a general acceptable framework around responsible AI solution. And your work and role as a data scientist, machine learning engineer, AI expert is to understand this framework, knows how to apply it when you are building your solutions and models, which I will talk about them one by one. And not just to talk about them, how can you or how as Azure platform made it possible to use to apply these principles while building your solution. Okay, you can see from here we have the fairness, reliability, and safety. You should think about those things. Privacy and security. Of course, when this generative AI technology came up, you see the petition that, oh, we should pause it so that we can regulate it for the next 6 months. Let's pause any, research around it so that we can actually understand and regulate it. While I don't support that, we should continue to move at the same pace and reiterate because most of these solutions actually go through this framework, even though they're not yet perfect, but they are constantly improving. So, but it just let you know that privacy and security is part of it. It's not just bias or not being biased. Inclusiveness, transparency, accountability. The height of what I do when I build machine learning model is to check for feature importance, right? I know you also check for feature importance, but you aren't checking for it for the purpose of responsible solution. Maybe you just want to fine tune your model to understand which are the variables that contribute most to my machine learning model so that maybe can I refine it and take it back to the model. But here, you're going to see how you can apply all this framework to the entire solution and not just the fine-tuning of your model. So let's start with the first one, fairness and inclusiveness. AI system, machine learning system should treat everyone fairly. You agree with me? And avoid affecting similarly situated groups of people in different ways. If we are the same, treat me the same way. Don't give something to someone and leave the other one out. For example, when an AI system provides guidance on medical treatment, loan applications, or even employment process, which are the scenarios I've cited today, they should make the same recommendations to everyone who has similar symptoms because they're expected to also have similar recommendation, financial circumstances, or even professional qualifications. So it shouldn't be financial circumstances here is can you pay back? That is affordability, ability to pay back. Those are the indices that should be measured rather than salary or no salary. Someone that is not earning salary can, earn times 10 of a salary earner's, income in a month, and yet you are denying that person of accessing credit facility, while someone who earn less is being granted that loan. Okay, so in terms of fairness and inclusiveness, it should include not just salary earners but also people who can afford. That's the concept of fairness and also being very inclusive. It should not be gender biased. Maybe it favors more in terms of roles. The way people describe job roles in some cases today, there are some keywords that are being used that made it favor more of male, that female gender sort of moved out and said, no, I think this is going to be too hard for me. Or in the course of evaluating the applications tends to favor, male over the female. Those things are not inclusive. Those are not fair. And you should look at that. A good example of how you can check for fairness is when you are trying to train your machine learning model, you can do a table just to look at what is the number of male gender in case you have categorical variables that you're using in your model. Take all the categorical variables, look at the counts. The moment one is over 87% or over 83%, be careful, because there's likely, if there are two categories, for example, and there's one group where you have, for example, gender, you have female, you have 83%, and you have female, you have male, and you're having something like 17%. Be careful, because there could be some level of bias, being introduced into your model, simply because the male representation might not be representative enough of that scenario you're trying to model. So in that case, female will be more projected than male. So that's one thing you can bear in mind. Oh, how can we do that? Let's try to balance our data set, get more data sets, or check out for other possible entrance for fairness, for unbiased biasness rather. So on Azure, how is it being done on Microsoft Azure? So fairness and inclusiveness in Microsoft Azure Machine Learning Studio. There is a component called responsible AI dashboard. When you build your machine learning model, even through the drag and drop feature or auto ML, or even writing your code and deploying within Azure Machine Learning Service, you're going to see it's currently in preview. The last time I built model, I still saw it and I enjoyed working with it. It enables data scientists and developers to assess model fairness across sensitive groups. Because fairness always affects categorical variables. When you have categorical representation in your model and they are not well represented or balanced, it's likely to introduce some level of biasness. For example, gender, ethnicity, age, and other characteristics. And that dashboard gives you a breakdown so that you can see how those things span across these categories without you writing extra code. So fairness and talking about responsible AI, it is not about additional work. No, it is rather being conscious of it and making it a best practice. So if you are thinking, oh, do I have to start learning new things? You could learn how to use these features on the platform, click, check, and do all those things. So when you are building your code, you can also use some explainability libraries just to have a better understanding of the model you have built. Right. So the fairness and inclusiveness is what check for biasness, because that's where bias is being introduced. If it is not fair and inclusive, then it is bias. So that feature for fairness and inclusiveness is the one for bias. So you see that feature under the screen. Once you build your model on Azure Machine Learning Studio and is deployed, the moment the model is done training, once you go to the model tab, you will see explanations, you see those different things I'm talking about, like fairness. Some of them are in preview. You can click on them and see the chart and see the breakdown. Okay, we move quickly to the next one, which is reliability and safety. You definitely don't want to use something that is not safe. You don't want to use something that is not reliable. For us to use these solutions, we need to trust them. So trust is critical. At Microsoft, Trust AI is something that we embrace. This is why it goes through a lot. We invest a lot in this aspect of responsible solution. Trust. To build trust, it is critical that AI system operates very reliably, safely, and consistently. So the moment your model is reliable, is safe, and is consistent, you don't give the model something input and it's giving you different output, and give you the same input, the same scenario, and it's giving different output, then it's not consistent and reliable. This system should be able to operate as they were originally designed, and not like, oh, all of a sudden it's doing something else when it should be doing what it has been designed to do. So responsibly to anticipated conditions, assist and resist harmful manipulation. Let me cite a good example today. If you go ahead and you Bing chat, you realize when you're asking some questions, it will literally not answer you the moment it's breaching trust and safety rules. Asking about are you sentient or not, definitely it's not going to answer you. This is examples of ways and manners through which Microsoft has incorporated this principle into their solution. And for you, it's to also leverage the feature in Azure as well. The error analysis is a way to test if something is reliable, if something is consistent. If it is consistent, the error should be very minimal. If it is reliable, the error should be very minimal. So the error analysis component of the responsible AI dashboard is what helps you to answer this question: how reliable and safe is your solution? So you can get deep understanding of how failure is distributed for a model. Oh, you can run many experiments, and you have several jobs running. Then you check the error logs. You see the error analysis. You're able to see, oh, this model using this particular algorithm with this parameter, this is the error distribution. When the parameter is tuned or the algorithm change, this is the error distribution. Okay, when you are bearing that in mind, not because this model is giving me 99% accuracy or 99% depending on the evaluation metrics you are using, but rather that this model is also answering the error part, the reliability part of it. So you're also putting that into consideration. That is how to think responsibly with your solution. Let's talk about transparency. When AI systems help inform decisions that have tremendous impact on people's lives, most of the solutions we use today do that. It is critical that people understand how those decisions were made. Why did you give someone loan and you did not give the other person? So explainability. For each, you must be able to interpret it. For each decision, what contributed to you making that decision? And that is also available in Azure. Even if you use Power BI, for example, to train the machine learning model, you will see all these analysis there. When you apply or deploy your machine learning model in Power BI, take for example, you're definitely going to see for every prediction, if I predict for this person loan approved, there's going to be a column called explainability column. If they tell you what variable contributed to that prediction, why did we give this guy this? Because the age is 8, because this is this, because the gender is this, because this is the total revenue that has been made in this month. And based on the algorithm that has been trained, these variables matter towards if the person will pay back or not. You see, that is real explanation. You are not just building a black box that nobody could explain, and the moment you cannot interpret and explain, then it is not transparent. Right. I see there are questions. I'm going to come back to them. Please keep your question coming. Thank you, guys. Right. So how is it being done on Azure? Of course, transparency in Azure machine learning, the model, of course, we talked about being interpretable. And we have a view called interpretability and counterfactual what-if component. So that element has two major things. First is the global explanation, and two is the model explanation. Well, actually, there are three: the global, the local, and the model. So that's how it's being cascaded. Still talking about being able to explain what the decision, the reason behind your model decision. For example, at the global level, what features affect the overall behavior of a loan allocation model? Global, what feature at the global level? So that's what feature importance does. At the local level, for example, why was a customer loan application approved or rejected? So your model feature importance is general to the entire model. But for loan for every customer that is approved, then why was it approved for this customer? Then you see the feature that contributed to that. That is local to that customer. Then, model explanations for a selected cohort of data points. For example, what features affect the overall behavior of a loan, which we have even talked about. Apologies, I'm missing this up. There are only two explanations, which are majorly the global and the local. The global is at the entire model level, the local is for each element. And when you are done building your model and you are checking these solutions, so you should look at that local level, do some analysis, some deep dive analysis, just run it. Yes, I know these are the feature important at the global level, but for those approved, why? What is common to them? Why are they being approved? For those rejected, why are they being rejected? And you could establish an already existing hypothesis, which to say, oh, I know people with low income will not be approved for a loan of this category. Does that hypothesis truth stands? You definitely check that out by doing a deep dive, do a further analysis on that explanation that you have, because you can still drill down there. Moving on to privacy and security. That's a major concern. How do I know engaging with the AI solution? How do I know, giving this model all my financial status, so that I can get a loan? How do I trust this? Is it secure? How, why do I have to give and tell my entire career story to, on the platform? Is it safe to do that? Why do I have to give up my medical history to an application that is going to help me to diagnose if I'm going to have a complications or any illness in the coming weeks? Why do I have to? You can't do that if the topic of privacy and security is not addressed. So as this whole thing become more complex, the capability of AI, privacy and data security require close attention. And that's under governance, which today on Azure, of course, even at Microsoft, there are two major things that is being done, the smart noise and the counterfeit. For the smart noise, we've created two open source packages that you can use to get this done. Because assessing the privacy level of a model is hard to tell, except you have a solution or a library that will continually help you monitor, evaluate, just like the way we do accessibility for websites. When you build a website, you want to be sure, is this website accessible? You run accessibility checks, you look at several components and elements. So also is this library, the smart noise and the counterfeit, that helps check for differential privacy topics. Take, for example, smart noise. It's differential privacy is a set of systems and practices. Let me explain that first, that help keep the data of individuals safe and private. When people interface and call the API and supply their information, if you have that library, it will secure and ensure that any privacy policy rules you have applied, this data should only be used for this assessment, should not be returned to another database where you are now using that information to do something else. This data should be used for the purpose it is intended for. You want to use this to assess if I'm eligible for loan, it should be used. And that's at the engineering level. So this kind of libraries ensures that the data is being used for that purpose. It runs checks and is able to check for compliance. That's regulatory topic here. The counterfeit is also an open source project that comprises a command line tool and generic automation layer to allow developers this time around to simulate cyber attack against AI. Today, because of data everywhere, there are a lot of cyber security attacks everywhere, trying to hack account, try to hack into AI solution. There is a reported breach at a point where some people logged into a mobile app and they were able to access loan up to hundreds of millions. They were able to crack it, hack into it, cybercrime, and applied and game the algorithm, then apply got approved. And imagine that. So you also want to test, sit back, simulate the scenario, and make sure that, this model is secure, and in terms of privacy and compliance, it is there. Don't forget, part of the principle is also accountability. The people who design and deploy AI systems must be accountable for how their systems operate. You can't just say today, this is how we do, tomorrow it has changed. You must be accountable. Organizations should draw upon industry standard, and that's the best way. This is why Microsoft is leading the pack with these frameworks, not just giving people, but implementing. Every solution you consume on Azure, in Microsoft product, they've gone through this framework and rigorously tested against those principles. So it is also good that in your organization, wherever you work, find the industry standard and make sure you're also aligning with it. In the financial space, that's why we have the IFRS, different reporting standard, because you have to be accountable. People should do the same thing, and everywhere you go, the same concept should mean the same thing to everybody. It shouldn't mean different thing. Now, these norms can ensure that AI systems are in the final authority. Yes, there are decisions that they make decisions that affect lives, so they can also ensure that humans maintain meaningful control over those solutions. Otherwise, highly autonomous AI systems can, when not controlled or managed or regulated, the decision they make can actually affect a lot in our life and daily activities. So on Azure, there are topics around accountability, but within Microsoft Azure, it is based on DevOps principles and practices that increase the efficiency of AI workflows. For example, MLOps, machine learning operations. So you know that this is your data source, you are connecting to data source. The moment you only people that should have access to that environment have access to it, it's showing accountability. Then you move on to build your model. Data engineers get the model data cleaned and put it where you should use as a data scientist. And that thing is in a pipeline. CI/CD, continuous integration, continuous development, and MLOps is the other word for that ecosystem, that framework. And the moment you're done building your model, those principle and checks, they're already done. You test it before you deploy to production. DevOps engineer, QA test rather, check the solution against the set test criteria. And the moment they pass, and those criteria are actually according to the principle, that's why you now see, oh, how are you applying and operationalizing responsible AI in your organization? And that is where it comes in. We want to make sure that, oh, this model is not biased. Okay, in the error analysis, what is happening there is the score less than this. If it's not up to that threshold, maybe it should be rejected. It's not going live. You have to go back and ensure you correct whatsoever discrepancies observed. So that way, Microsoft Azure manages it. I'm just going to give you an oversight view of how responsible AI dashboard on Azure works. And we won't be able to do practical sessions of it today. First two things here, model debugging and business decision making. Because the model itself, there are a lot of things that can go wrong within your model. And decision you are trying to make can actually go wrong if you are not careful. So this is why, first, it provides you with all these things: error analysis, data explorer, model overview, fairness and assessment, model interpretability, counterfactual, what if scenario, still under your model building. So you built a model, but these are things that today you don't even pay attention to them as you should, because you are not aware of the impact they make. But now that you understand and you see a tool that can even help you get this better, it is time to start paying attention to those dashboards and use them. When you're making business decisions, that's the most critical part as well, because the model you built is to be applied to the business to do something, either to increase revenue, to make customer more happier, or to lower cost, or to make your process more seamless. It's applicable to the business. So when you are making that decision, you need to carry out what we call causal analysis. What if this? And counterfactual what if scenarios. What if this happen? What will be the implication? The last time I demoed a machine learning solution using Power BI, I was able to do that business what if scenario. What value will this model build if my ROC curve, is at a particular threshold? How will that impact the business? What am I losing? What am I gaining? That way is about decision, and you can play with those what if scenario on those dashboards. Right, almost getting to the end so that we can answer questions. It shouldn't be a long session. It's just be saying that introduce you to this concept. Model debugging via responsible AI dashboard on Azure. These are the things that I mentioned the other time. However, they are actually across three categories: identify, diagnose, and mitigate. It's ensure that it mitigates, and it's a backward compatible solution. So the moment it goes right and check for something is wrong, find a way to mitigate it, go back and check again. If you find another error, go back again and mitigate. It's in that loop, making sure constantly that there's no oversight. The moment you fix a problem with error analysis, you could have actually resolved error analysis, but fairness assessment would have gone up again. So you need to be sure that it's not just to fix error analysis, check again, and overall making sure everything works well. So the error analysis, model interpretability, and these are things we talked about. Unfairness mitigation, that help you to mitigate with suggestion, mitigate fairness issues. Data enhancement, enhance your data set and retrain the model. So you can do that as well in cases where there are some unbiased data. Fairness assessment help you to identify. So these categories, the first category we have here, which is identify, helps you to identify error or issues. Here it diagnoses it. Here find ways to mitigate that thing for you, making suggestions for you. You should do this, you should do that. And when you make those changes, go back again and check, and you can see most of the time they get solved, or it could result to making business decisions to say, oh, should we go with this, or what should we do? Almost going to the last part now. Decision making we've talked about two things. First is the model itself, the second one, which is the technical, the code analysis, the second one is the decision business is making. And right here, you see that it does two things: understand data and to inform actions. The data you're working with, it helps you to understand data set characteristics through exploratory data analysis. All the things you are doing, there's no way to tell if there's going to be biasness if you cannot check what categories you have your data and are they likely to introduce bias if they are not balanced. So in the course of exploring your data, exploratory data analysis, that's where you can identify and understand that data better and can inform the actions and decisions you are making. We have the causal inference, understand the causal impact of your features on real-world outcomes. The fact that your model is predicting 100% doesn't mean when applied to real world it's going to be the same thing. All this advanced technology that we use today, before they are being released, that is why they go through the series of tests: private preview, public preview, general availability, because they need to be, you don't just release them because of the impact they have on the ecosystem, on the world generally. So you need to test, reiterate, go back again, make update, and make sure it's improving up to the point that it's reliable. Counterfactual analysis generates diverse counterfactual explanation for informing end users. So for example, that what if scenario now, you're going to see that what if this happened to me? How is this model going to affect my business? Or how what's the implication if this model approved 10 people to get loan, meanwhile they are not they are not eligible? Would that be bad loan? What impact would that have on my business? Or what if we could approve 10,000 loans, but out of that 10,000, 9,000 of them are good ones that we observe that likely they will pay back, and 1,000 they are not going to pay back. So what is the impact of that on my business? Is the cost benefit analysis, is it worth it? And I haven't talked about those features which doesn't require you writing code, but as things are already there, that when you build a model, some of them comes out of the box. It's just for you to explore those features. And then when you're engaging with business, you use those things to drive your decision, your discussions. You not just say we build a model and this is the API and you demo how it works. You should be able to talk responsibly around two topics: the code itself and also the business decisions. So the moment you could touch those parts, it shows that you understand. Those are the questions that will be coming from business, but now that I could talk to them about it, they have more confidence in what you do. Even if they are not paying attention now, hide it. When you are reporting on your project, I'll build this model, and these are the responsible part of it. We are building a solution that's responsible day by day. This is where the things we observe. In this case, it's not so perfect yet, but we're going to reiterate and make sure we improve on the model so that we can lessen or lower the error analysis or the fairness of this model fairness score, all those things. Even when they don't know what it is, they start using it because you are the one who is building this solution and you have to be accountable. So why should you use the responsible AI dashboard of Microsoft Azure? There's no central location to discover and learn about the tools, extending the time it takes to research and learn new techniques. When I learned about responsible solution explainability, then I have to use there were only two libraries available, open source library, and I have to start learning and use them. It wasn't an easy call for me. And for you today, all the things you need, you can still see them right there on the dashboard and use them to make your decision. So these different tools don't communicate with each other. When you are talking to data somewhere, building data somewhere else, you deploy your model in another place, the DevOps or machine learning operation aspect is scattered. And many companies today does not trace them. You don't even have any tools to manage the CI/CD or the ML ops process. However, within Azure Machine Learning Studio, you know that the responsible AI solution is not just talking to your model, the entirety, the data itself that you connect to, because it does EDA, exploratory data analysis, to understand your data, don't forget. So it connects to every asset, every element of the solution that you are building. That way, it can give you more comprehensive analysis. You run good data, you build your model, the metadata about it, and many other things in between. Lastly, the metrics and visualization aren't easily comparable, and the results are hard to share. Today you compare something, your model, you can't even interpret the comparison. But with Azure Machine Learning Dashboard, you are able to interpret. Many of them are even interpreted. You can see some intelligence being already there to help you understand. There's some explanation to say, oh, this is what this thing means. This is how to read and interpret this chart, this bar, this this number, this is how to interpret them, on and on like that. So beyond having everything in one place, you don't build your model and go to another place to do interpretation. It is there. You can follow with the responsible element of it right on Azure Machine Learning Studio. Okay, like you've guessed, we'll come to the end of this. I want you to take it not as a learning, but as something that will be part of your daily practices. So any model you build today, even if the Jupyter notebook, add the chapter to the end of the notebook, responsible solution. So what are the frameworks? Which of them were you able to capture in your project? Which of them could you not? The fact that I cannot capture them now is because maybe you are not on Azure Machine Learning Studio. If you are there, you'll be able to capture them. But being mindful of them goes a long way to improve on your career and what you do generally. Okay, we could take one or two questions before we call it a day, if there are questions. Oh, I see a question. Okay. Do I have to tell Azure Machine Learning which features should be checked for bias? No, not at all. When you build a model, because it's just explanatory analysis, and that's the very first point to understand biasness. When you do exploratory data analysis, EDA, when you explore your data to understand your data, and you start looking at the categorical variables in the data set, which is going to be part of the input in the model, those are easier way to introduce biasness. So the model, the algorithm, try to check that for you, understood and pick those as trigger that there's going to be likely some biasness being introduced from this categorical variable because they are categories, they are cohorts, and if not properly checked, one category can be biased if the data is not balanced, and so many other features. So it does it for you for every features, categorical features most importantly. I hope that answers the question. The other one we have here is, do the models that are created have a spec that can be looked at to determine the representative data set and its creation criteria? I want to assume right here that you are speaking to the model that you built, that doesn't have the specification that can be looked at. Okay, so let me speak to this based on my understanding. When you build your model, you have access to the data yourself. You train the algorithm and you build the model. When you are building and you're exploring, you do ED as well. You try to, most of the time we call it, we have exploratory data analysis. You explore, and while you're exploring, you are checking all those categorical variables, you're understanding your data better, and you are using those information to create new columns. So it is when you have unbiasedness that you know that one is not representative enough. If you have gender, for example, if you have bias, sorry for that. If you have gender and you're having male, female, you're having 90% male, 10% female. Obviously, there could be issues there because you don't have enough data representative of that category. If there are 3 or 4 categories and some categories were low, not a problem because they were distributed separately. And even in those scenarios, you might not have enough data point to tell you exactly that is representative of what is happening to that category of or that segment of data point. So it is you, when you are running your analysis, you are exploring your data, that you check for those things, and you don't confirm immediately if there's biasness or not. When you go back after building your model, you check from the fairness scores and all those things, then you know that, oh, there's a biasness. I've anticipated it because I took notice of the likelihood of having this because the data was not balanced, something like that. I'm not sure if that answers your question. Which algorithm or library does Azure use for its explainability feature? So in terms of algorithm, it's not just a single algorithm. So let's put it that way. It is rather a best practice framework that was developed. When you build a model, every model has elements. Your data have metadata, everything is exudes data when you are working. Even the how long it takes to build, to train your model, the kind of evaluation metric that was used, they have metadata. But these are metadata we don't access. either because they are passed along as variable subclass in the model in the code we are writing, and we don't even always call them. And what they focus on is when you build a model, these metadata, let's collect them and let us evaluate and apply the machine learning principles. Let us aggregate some and calculate some scores. So it's engineering plus best practice frameworks. And of course, we talked about two libraries that were being used for assessing security topic under compliance. Let me quickly go there, which is Smart Nose. This is a library and it is actually co-developed, co-developed by Microsoft, as well as Counterfeit, which is also another library. In this scenario, these are libraries that is being used for those purposes. Okay, and thank you. If there's another question, you can take that.
Yeah, I think that was the last question. But thank you so much, Ola, for the session. Thank you, everyone, for joining in. I've pasted all the links that you might need on the chat. So I think we'll end the session there, right, Ola?
Yep.
Okay. Thank you, everyone,
But
and have a good
I should give
evening.
a final note, and because I want
Yeah.
them to go ahead and leverage these things we talked about within Azure Machine Learning Studio. So the moment
Yeah.
you've gone to the studio, you should have deployed your model from the scenarios and the different use cases in this learning journey. Go there, check that model. You will see this feature that I've talked about. You will see them there. You see fairness. So click on it, explainability. Wow, yes. You're going to see how much of work has been done to make sure that you are building a responsible solution. So thank you and bye.
Thank you. Thank you for that. And thank you, everyone. And goodbye.